Good morning, students. In this video we will discuss about electromagnetic spectrum. You have studied in 9th class about wave. You know, wave propagates energy or transmits energy. The function of a wave is to carry energy or transfer energy from one place to another place. There are two types of waves: mechanical waves and electromagnetic waves. About mechanical waves you have studied in 9th class. They are the waves produced by the vibration of matter, solids, liquids, gases. When they vibrate, mechanical waves are produced, and these mechanical waves require a medium to travel. They can't travel through vacuum. Sound is an example for mechanical wave. You have studied in detail about sound waves. Now, the second category is electromagnetic waves. These waves are produced by accelerated electric charge. You know, electrons are having some energy. They have charge, and this electrons, since they have charge, they have an electric field around it. Like the magnets are having magnetic field, electrons are having an electric field around it. When these electrons are accelerated means they are shifting from one orbit to another orbit. That is possible by certain methods. So when electrons are accelerated means when they move with acceleration, due to its motion some magnetic field is also produced. So the conclusion is, an accelerated electron is having both electric and magnetic field. Magnetic field is due to the movement. So this electric and magnetic field produced by an accelerated electric charge, it makes an electromagnetic wave. So we can say electromagnetic wave is a combination of electric and magnetic field, and these two fields are perpendicular to each other. So these are the two classification of waves: mechanical waves and electromagnetic waves. And electromagnetic waves are of a wide range, and the arrangement of all the electromagnetic waves in a particular order, that is known as electromagnetic spectrum. And here I have written the different components of electromagnetic spectrum or different types of electromagnetic waves. Starting with radio waves, then comes microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. These are the different electromagnetic waves. And this order is in the decreasing wavelength. I mean, when you move from radio waves to gamma rays, wavelength is decreasing but focal frequency increases. They are inversely related. Wavelength is highest for radio waves and it goes on decreasing. Gamma rays are very short waves. So from radio waves to gamma rays, wavelength is going on decreasing but frequency is going on increasing. Then reverse, when you move from gamma rays to radio waves, wavelength is going on increasing, frequency is going on decreasing. Okay, so these are the different types of electromagnetic waves, and this group of electromagnetic waves together we call as electromagnetic spectrum. You have to remember these names in a particular order. Either you remember from radio waves to gamma rays or reverse order. You must know. You may get a question: arrange the different electromagnetic waves in the order of decreasing wavelength or increasing wavelength. So you must learn these names in order. These are the different electromagnetic waves. Then Out of these, different electromagnetics are having different wavelength range and different frequency range. Okay, then in your textbook the frequency range and wavelength range are given. You need not by heart it, just understand the change in the frequency and wavelength. Okay, so these are the different components of 7 different components of electromagnetic spectrum. Then out of this, the middle one you can see, that is visible light. That is the light with which we are able to see the objects. And this visible light, its wavelength range I discussed in the previous video. It is from 4000 angstrom to 8000 angstrom. You know, this visible light is having 7 colors, Vibgyor, and here this order is in the order of decreasing wavelength. So here violet comes, violet, indigo, blue, green, yellow, orange, red, Vibgyor. These are the 7 colors of this visible light, and its wavelength range is from 4000 angstrom to 8000 angstrom. 4000 angstrom to 8000 angstrom. This is the wavelength range for visible light. The colors close to 4000 angstrom wavelength, they belongs to violet category. They give us a sensation of violet light. I mean, an electromagnetic wave of 4000 angstrom, if it enters into human retina, you will see that object from where this electromagnetic wave comes in violet color. Similarly, from an object, how we see an object in red color? When you look at an object in red color, from that object an electromagnetic wave enters into your eye, which is of wavelength near about 8000 angstrom. So you will have the sensation of red color. You will see that object in red color. Okay, so this and in nanometer, if you say, it is 400 nanometer to 800 nanometer. This is the wavelength range in nanometer unit. Then why the name is given as visible light? Because human eye will respond only for this small group of electromagnetic waves ranging from 4000 to 8000 angstrom. Okay, all the other electromagnetic waves like ultraviolet, X-rays, gamma rays, infrared, microwaves, radio waves, these electromagnetic waves cannot make any response in human retina. Okay, these 6 electromagnetic waves make invisible spectrum, and only these electromagnetic waves coming under the range of 4000 angstrom to 8000 angstrom makes visible spectrum. Means this is the only electromagnetic waves visible to human eye. Then another point, the 2 boundary colors of visible light are violet and red. Did you notice the neighboring region of violet is given the name ultraviolet, since they are this ultraviolet rays comes after violet, its name is given as ultraviolet. Similarly, the other boundary color is red, and the region close to red is given the name infrared. Since violet and red are the boundary colors, the neighboring 2 regions are named with that terms: after violet, ultraviolet; before red, infrared. So the 2 neighboring regions of visible light in electromagnetic spectrum are ultraviolet and infrared. Then now we will discuss some general properties of these electromagnetic waves. Common properties. Listen to it. First property, some properties which I am going to discuss here is not included in the textbook, so you may add it in the textbook, the points. All these electromagnetic waves can travel through vacuum. They do not require any medium. Even through vacuum, all these electromagnetic waves can travel. This is one general property. Another one, all these electromagnetic waves can reflect. You have studied about reflection of light. Not only light, all electromagnetic waves can reflect. Another point, all can refract. You have studied refraction of light. Not only light, all electromagnetic waves can refract. Then all can travel with the same speed in air and vacuum. Not it. In air and vacuum, all the electromagnetic waves travel with the same speed. Then all these electromagnetic waves are transverse in nature. Transverse means, why they are called transverse is their electric and magnetic field. These waves are having electric and magnetic field, and these fields are perpendicular to each other. So they make a transverse wave. Then these electromagnetic waves are produced by the accelerated electric charges. Then these electromagnetic waves are not deflected by any electric or magnetic field. These are some general properties of electromagnetic waves. And now we will discuss the certain properties of these different particular properties of or special properties of these electromagnetic waves. We will start with the gamma rays. You know that is the shortest electromagnetic wave. And the radio waves are the longest waves. That means when you hear the waves are very long, and as you go towards gamma rays, they become the short. Okay, the shortest electromagnetic wave is gamma rays, and the longest one is having highest wavelength is radio waves. We will start with the gamma rays. Gamma rays, they are having very high penetrating power. Okay, they are having very high penetrating power. Even through a metal sheet they can penetrate through. Then they can pass through human body. Then thereby it makes some biological damage. If gamma radiations pass through human body for a long time, it makes some biological damage. Not only to human beings, to all animals and plants. The long exposure of gamma radiations make damage. Even genetic disorders can happen if our body gets overexposed to gamma radiations. Then among all these electromagnetic waves, gamma rays make the maximum biological damage. And these gamma rays are produced, their sources are nuclear reactor, or wherever radioactive means from radioactive materials these gamma rays are emitted. So during nuclear explosion, or while in a nuclear reactor, when nuclear reaction takes place, large amount of gamma radiations are produced. Then their uses, they are used in the treatment of cancer, radiography, all this. And overexposure of gamma radiations can cause cancer. At the same time, a controlled use of gamma radiations are helpful in the treatment of cancer. And gamma radiations can cause fluorescence, a phenomenon called fluorescence. A phenomenon called fluorescence. It is shown by certain chemicals like zinc sulfide, barium platinocyanide. In these chemicals, when gamma radiations of very short wavelength falls, this chemical will absorb it. It absorbs this gamma radiations, and it will be re-emitted after increasing the wavelength. Means the waves entering or falling into the solution are of short wavelength like gamma radiations, and this chemical will alter its wavelength and it will be resent after increasing wavelength. And this increased wavelength, it makes visible light. You know, when gamma radiation's wavelength increases, it becomes visible light. Okay, then this phenomenon is known as fluorescence. The radiations entering into the chemical is invisible, but the radiations emitted from the chemical will be visible. This phenomenon is known as fluorescence. So gamma radiations, they show this phenomenon, and they are detected by this phenomenon also. Fluorescence is a method to detect these gamma radiations. So this is about gamma radiation. Now comes X-rays. X-rays are chemically active than ultraviolet. Ultraviolet radiations are having chemical effect. X-rays are also having chemical effect, and their chemical effect is more than ultraviolet radiations. And X-rays are used to find out the fracture in the bonds in the field of medical field. Okay, if any fracture happens in the bond, we take the X-rays. The reason behind it, X-rays are having penetrating power. It can penetrate through human body, through human flesh, but it can't pass through bonds. So bonds will stop them. So if you keep a screen behind, the trace of the bonds will be seen clearly. It is one use of X-rays. Then they can affect the photographic plate. If X-rays are falling on a photographic film or plate, it gets activated, or chemical reaction takes place. Then fluorescence is shown by X-rays also. These are some characteristics of X-rays. Then another point which is not given in your book, X-rays are used in the study of crystals. You may note down this point. Then comes ultraviolet radiations. They are having chemical effect, and thereby they are used for the sterilization purpose, for the surgical instruments and all. Sterilization can be done with the ultraviolet radiations. And these ultraviolet radiations, they are produced by hot objects which are of very high temperature, like sun, electric spark. Means the sources, hot sources which are of very high temperature, they are the sources of ultraviolet radiations. And these ultraviolet radiations, they can also affect photographic plate like X-rays. They are and also they have fluorescence. Remember, all these three are having fluorescence. And overexposure of these ultraviolet radiations are harmful to human body. Okay, then these ultraviolet radiations are helpful to us also. It helps the body to produce vitamin D. Okay, if our body gets exposed to ultraviolet radiations, it produces vitamin D. These are some uses of ultraviolet radiations. You know, in water filters, UV system is there, that is to kill the germs present in water. These are some uses of ultraviolet radiations. And these ultraviolet radiations are also used for sterilizing the food items. Sterilization of surgical instrument, sterilization of food, all these can be done with ultraviolet radiations. And also adulteration in food items can be detected by ultraviolet radiations. These are some uses which are not given in the book. And another thing, the fake diamond you can detect, fake currencies you can detect with the help of ultraviolet radiations. You might have seen in banks, the cashier, the accountant, he counts the notes under a particular lamp. Just above him you might have seen a lamp, that is ultraviolet lamp. When he counts the currency, if fake currency comes, easily it can be detected under an ultraviolet lamp. Same way, fake diamond, original diamond and fake diamond you can identify easily with ultraviolet radiations. Then if any fake documents are there, if any erasing is done in any document, it can be easily found out or detected under an ultraviolet lamp. These are some uses of ultraviolet radiations. Then comes visible light. You know, it helps us to see the objects. It is used in photosynthesis, and its source is hot objects. In your textbook, by mistake, it is written not objects. It is hot, H-O-T, hot objects. So sun is a main source of visible light. Ultraviolet also is produced by sun. Then some characteristics of visible light. Visible light, its characteristics are given in the book. General characteristics you can include what I told. It can reflect, it can refract. That is applicable for all, not only for visible light. They travel with the speed of 3 into 10 to the power 8 meter per second in air and vacuum, and they can affect the photographic plate. Then one point is wrong here. Fourth point, page number 135. Under the title visible light, fourth point, absorbed by glass but transmitted by rock salt. That point you have to cut. It is not absorbed by glass. Glass transmits visible light. So fourth point you have to delete. Then they have heating property. If light falls on an object, it gets heated up. It is used in photosynthesis. These are the uses of. Then comes infrared radiations. They are having heating effect. Ultraviolet radiations are having chemical effect, and infrared radiations are having heating effect. And these heat radiations are used. It is used in several places. You might have heard about infrared photography. In ordinary photography, we use visible light, but you can't have ordinary photography in darkness. An object which is in complete darkness, its photography is impossible with the ordinary camera, because in ordinary camera, visible light is required to take a photo. Okay, so and ordinary photography can't work in a foggy weather, in a dusty weather. Okay, it can't. Ordinary photography will not give a clear photo, but infrared photography is there. That photography is very useful in foggy weather, and where if it is atmosphere is dusty, it can give a clear image. That photography is called infrared photography. In infrared photography, what is used is the heat radiations. Infrared radiations mean they are the heat radiations, and it is emitted by any hot object. Remember, in these three cases, ultraviolet radiations are emitted by very, very hot objects, and visible light by hot objects, and infrared radiations are emitted by all type of hot objects. Even from human body, some infrared radiations are coming out. So any hot object can emit infrared radiations, but ultraviolet radiations can be emitted only by very, very hot objects. Remember this point. So in infrared photography, the heat radiations coming from the body of an animal, it makes the image. In ordinary photography, visible light coming from or reflected from an object makes the image. Here, heat radiations make the image. So these waves are of longer wavelength than visible light, so they can easily travel through the fog or smoke or dust. They are not getting scattered easily like visible light. Due to all these reasons, infrared photography is successful in foggy weather. Then another point, these infrared radiations cannot affect the ordinary photography plate. Special photography plates are to be used for it. And high dose of these infrared radiations are harmful to human body. Then another thing, you have to add one point here, important point regarding ultraviolet radiations in visible light and infrared. For the study of visible light, we use glass prism. Glass prism, this point is not mentioned properly in your book, listen to it. For the study of visible light, we use glass prism. But for the study of ultraviolet and infrared radiations, you cannot have glass prism. The reason is glass will absorb these radiations. That means that radiations can't come out or can't be transmitted through glass. So special type of prisms are used for the study of these infrared and ultraviolet. For infrared radiations, for the study of infrared radiation, rock salt prisms are used. Rock salt prism. And for the study of ultraviolet radiations, quartz prism is used. Because quartz will not absorb these ultraviolet radiations, or through quartz ultraviolet radiations can come out. Thereby, for the study of ultraviolet radiations, quartz prism is used. Similarly, for the study of infrared radiations, rock salt prism is used because rock salt transmits infrared radiations, but glass will absorb them. So for the study of infrared and ultraviolet radiations, you cannot use ordinary glass prism. This is important point to remember. One more point, for ultraviolet lamps, its cover will not be made with the glass. Ordinary bulb, its cover is made with the glass, but for ultraviolet lamp, its cover is made with the quartz material, because glass will not transmit these ultraviolet radiations. They can't come out. So quartz envelope is used for ultraviolet lamps. Then comes microwaves. They are of long wavelength. They are used for cooking purpose, and they are used in the study of atomic and molecular structure. They are useful in communication. Then comes radio waves. Among all these, they are the long waves having very high wavelength. They are used for the communication, TV, telephone, radar communication. They are radio waves. Radar is used in aircrafts for sending the signals. Their radar, its full form itself is radio detection and ranging. Their radio waves are used. Long waves of radio waves are used. So remember, in telecommunication purpose, microwaves and radio waves are used. It is also used, both are used in telecommunication, microwaves and radio waves. These are the general properties of electromagnetic waves. Then exercise, this chapter 6 is over. Exercise questions you can do by yourself. There are some numericals from page number 137. There are 3 numericals. All the numericals are based on the formula V is equal to F lambda. This is general formula for waves. V for velocity, F for frequency, lambda means wavelength. Based on this equation, you can solve all the 3 equations, all the 3 numericals. And page number 137, multiple choice questions 4. Page number 137, on the top you can see one multiple choice question, that is 4th one. Electromagnetic wave is produced due to the periodic disturbance of, 4 options are given and the correct answer is 3rd one. Here it is printed 2nd, that is wrong. 3rd one is the correct option, both electric and magnetic field. And in this chapter, one more topic is given, scattering of light, that is now excluded from the syllabus. So with this, 6th chapter came to an end. You can watch the video, learn the chapter, do the exercise questions. Okay, thank you.